response to the need for a valve that specifically addresses the physiological characteristics of normal pressure hydrocephalus, Integra introduces the NPH low-flow valve. While a typical DP shunt is designed to maintain a constant differential pressure regardless of the flow-regulating NPH valve is designed to maintain a constant flow rate regardless of the differential pressure. The practical applications of these opposing theories are the following. For the DP valve, pressure is the critical component for functionality, while for the flow control valve, flow is the critical component for functionality. The concept behind flow regulation is analogous to how an eyeball works. As varying amounts of light enter the iris, the pupil dilates more or less accordingly, so that the eyeball sees the same amount of light. Likewise, as varying amounts of CSF enter the valve, the diaphragm moves up and down accordingly, so that the valve sends out a constant flow of CSF. What this logistically means for the NPH shunt is that once the CSF starts flowing through the valve, the seat moves up and down along the pin to allow more or less fluid through it as it exits the valve. This always open valve functionality allows for the desired result of a constant flow rate. Stage 1 begins when the flow rate through the valve reaches 5 milliliters per hour. The valve remains in this stage until the CSF rate goes up to 8 milliliters per hour. In stage 2, the valve operates as a variable resistance flow regulator, restricting flow between 8 and 17 milliliters per hour. That is in fact the flow range for an NPH patient. On the rare occasions when the IVP elevates abruptly, in stage 3, the shunt will operate in a rapid flow model to facilitate IVP normalization and then will quickly return to stage 2. Thank you for taking time to learn more about the Integra NPH low flow valve. To learn more, please contact your local Integra neurospecialist or call Integra customer service.